Okay, welcome back. We start this lecture by revisiting the example that we did in the previous lecture. A car manufacturer claims that the average fuel consumption of a specific model car is less than 5.8 liters per kilometer. Then the manufacturer collected some evidence in the form of a sample of size 20. The sample mean was calculated as 5.7. And we can also assume the population standard deviation of 0.22. We started by setting up our null and our alternative hypotheses. The null hypothesis that the mean is equal to 5.8, the alternative less than 5.8. So you can see that the alternative reflects the claim from the manufacturer that it's less than 5.8. Okay, and then we went through a whole process to find a cutoff value. Okay, and we found a cutoff value, or we calculated the cutoff value C as 5.72, and we said that if the sample mean is less than this cutoff value, we will reject the null hypothesis. The reason why we say that we will reject if it is to the left of this cutoff value is because our alternative hypothesis is a left-sided alternative. Let me just write it here, that my alternative is less than 5.8. So it's a left-sided alternative. So that is why we will reject the null hypothesis if the sample mean is less than my cutoff value. Okay, and our sample mean was 5.7, which is less than 5.72. So that is why we rejected the null hypothesis and then came to our final conclusion. Okay, and this is how far we got in the previous lecture. So that is also illustrated here in this graph. My null hypothesis is that the mean is equal to 5.8, and then we calculated a cutoff value, this 5.72, and we said that if my sample mean lies to the left of that cutoff value, I will reject the null hypothesis. And my sample mean was 5.7, it lies to the left of the cutoff, and therefore we reject the null hypothesis. So just for a little bit of terminology, the test statistic is a value that is calculated from the sample values. Now in our example, we calculated the sample mean from the sample, and we used that as the test statistic. And then the rejection region is a range of values, so that if the test statistic falls within this range, the null hypothesis is rejected in favor of the alternative. So for our example, the rejection region is the range to the left of 5.72. So our test statistic was the sample mean. It was 5.7. It lies somewhere over there. It lies to the left of my cutoff value. It lies within the rejection region, and therefore we reject the null hypothesis. Now, the rejection region is calculated in such a way so that the area to the left of my cutoff value, that area, that blue, is equal to my alpha, my level of significance. In our example, we have set alpha as 0.05, a 5% level of significance. So that blue area is 0.05. If our alternative hypothesis was a right-sided alternative, in other words, if we had something like this, then the cutoff value would have been on the right. And if my alternative was a two-sided alternative, then we would have a rejection region to the left and also to the right. Now, it's common practice to work with a standardized test statistic. So in the example, we work with the sample mean as our test statistic, but we can standardize it by subtracting the mean under the null hypothesis. So that mean is 5.8, and then we divide by the standard deviation, which is 0.22 over the square root of n, which is 20. And our standardized test statistic is then minus 2.03. And because we are working with a standardized test statistic, we can find the cutoff value or the critical value easily from the Z tables. So we want to find a Z value so that the area to its left is 0.05. In other words, we are interested in minus Z 0.05. And I refer you back to the following table. My Z 0.05 is 1.645. So minus Z 0.05 would just be minus 1.645. And if you are not sure where this table comes from, I refer you back to the lectures on the normal distribution. We also made use of this quite extensively in confidence intervals. Okay, so my minus Z 0.05 is just minus 1.645. So now my rejection region will be everything to the left of minus 1.645. So that is then illustrated here on this graph. My rejection region is everything to the left of minus 1.645. Because we are working with a level of significance, alpha, of 5%, that blue area is equal to 0.05. And we will reject the null hypothesis if the standardized test statistic lies to the left of my cutoff value, or if it lies in the rejection region. So my standardized test statistic is minus 2.03, so it lies somewhere over there. It lies within the rejection region, and therefore we reject the null hypothesis. So we can say that my standardized test statistic is minus 2.03. My cutoff value or my critical value is minus 1.645 because my test statistic value lies to the left of my critical value. It lies in the rejection region. We can reject the null hypothesis in favor of the alternative hypothesis at the 5% level of significance. So we come to the conclusion that there is enough evidence at the 5% level of significance to accept the manufacturer's claim that the average fuel consumption of this specific model car is less than 5.8 liters per kilometer. Now, if the null hypothesis is rejected, we say that the test is statistically significant. Okay, so to summarize this lecture, we say that it is actually common practice to find a standardized test statistic. So if we have a standardized test statistic, it is easy to find our cutoff value because we just make use of the values from the normal table, the critical values from the normal table, and then we can easily find our rejection region. And then if the calculated test statistic value falls within the rejection region, we will reject the null hypothesis.